Okay, so we're going to look at program flow and file structure with C file. I'm going to go ahead and fire up Windows Terminal for Kali Linux. I'm going to use, for this example, I'm going to use Visual Studio Code and the GCC file and the Windows subsystem for Linux too. Okay. Oh, no. Code. Okay, I'll open it. In the wrong folder. Go ahead and CD, the example, open code at the right place. You can see our Visual Studio Code now. And we have our Visual Studio Code all set up ready to go for C files. So start with structure is load files, go to the top, global variables, structures, and function. For an example, hash load standard io.h. This loads things like printf, etc. Functions you're used to seeing. Don't know. I like to use global variables unless I have to. We don't have any function signatures just now, so we'll go ahead and do our int main. And we're not sending it into it just now. We have our main function. All C programs need a main function. And inside that is local variables and code. Main program code. And after main we have our function bodies. That's the basic structure of a C file. Things go, and I'll go ahead and I'll add a bit more detail there, so it's user find function signatures and find function bodies. Go ahead and we'll do our little printf, throw out our hello world as normal. First program, and we'll go ahead and we'll going to use GCC 11 build active terminal. Go ahead. Hello world. Got what we said. That's the structure. Now we can program flows. Now all C programs, or in this case of this unit, programs run from the top of the file to the bottom. Now they may jump around a little based on how user-defined functions are used, but essentially wrote program flows from top to bottom. See an example of that by adding a breakpoint. Throw in another printf. Paste that, but we'll add 2 breakpoints. Makes the program pause in the logger. At this point, just as it reaches that breakpoint, runs down, brings in our functions, run through the hits main, executes main, and gets to line 12 and pauses right here. And it's printed hello world. It's now in 13. Pause before it does that. It'll print and it ends. Just like that. So that's our program flow, top to bottom. Now we can interrupt that flow, much like putting sand in a stream of water, by doing something like an if statement. If, let's just go for true. Statements always equate to true or false, don't they? Normal. Now do it work, so if 1 equals 1, it does, same thing as right and true. Does equal 1. We'll go ahead, add our program flow. Again, so our little jogger pop up. The flow of the program, it'll hit, it'll pause again at 12. 13. And it should jump right to 16 because 1 does equal to 1. Stop that. And if we change that, hit run again, We get our first two breakpoints, and the third breakpoint in line 16 shouldn't trigger because 1 does not equal. That breakpoint. Right again. Show not equal. Program flow. We can interrupt that flow, or we can control it. Or int counter equals 0. Counter less than or equal to 2. Plus plus. Ahead and our little program run. See the flow it should load. So again we'll get first 2 jumps down because 1 does not equal to 2. And you can see in this environment you can see your variable, so at this point counter equals 0 and it will run how many times? Pops out 3 times. See, we can control the flow.